Hey everyone, we're back on page 11, chapter 7 notes, continuing with population proportion hypothesis testing. This one, we've got a research center claims that 25% of college graduates think a college degree is not worth the cost. Okay, there's a random sample of 200. Of those surveyed, 21% reply yes, an alpha of a whopping 10%. Can we reject this claim? What I would like you to do now, try this one on your own and, pause the video while you do that, see how you do, and then hit play, and then you'll see the whole thing pop up, and then we can discuss it. Okay, so go ahead and pause now. Okay, so here's what I came up with. Hopefully it matches yours somewhat. But notice we have an H sub 0 as the claim because 25% think something, right? And so the opposite of that is not 25%, HA. So that makes this a two-tailed test because of the not equal sign. There's my Z-score. Notice that 0.21 comes from the sample, that's the sample proportion, and the 0.25 comes from the hypotheses. We got 0.25 again in the denominator, there's P again, and then there's the Q, 0.75, that's the 1 minus the P, and then divided by 200, which is the sample size, okay? So that works out to be negative 1.31. To find the p-value, you look up negative 1.31 in your table. So that value comes from the table right there. But then because it's a two-tailed test, you have to times by 2. So that gives your p-value of 0.9012. And then we're going to fail to reject H sub 0. That's because the p is larger than alpha. That's that comparison. And then you combine the fail to reject with the fact that H sub 0 is the claim. And so then there is insufficient evidence to reject the claim, okay? So there's a good summary of what we're doing so far in the p-value method. This can also be accomplished using StatCrunch. So maybe I'll show you StatCrunch real quick. We could try this problem with that method. So let's bring that up. All you need to do is just open a blank StatCrunch page, and we're going to go stat, proportion stat. There's a new location. One sample with summary. Stat, proportion stats, one sample with summary. This is the X and this is the N. So in this problem, the N, number of observations, was 200. The X was not given. So we only know that 21% replied yes. So how many people replied yes? What I'm going to do there is, and I could just type this right in here, taking 200 times, use that for times, 0.21. Or I can do that on my calculator too. Let's see if that works. Okay. Now, under hypothesis test, just put in the correct P, which was 0.25. It's a not equal by default, and that should work. So we got the same values, well, pretty close anyway. The Z-stat for sure, 1.31 negative. P-value, a little different just because of rounding. This one is actually more accurate, okay? So when I go back to that, this up here might have been a little confusing. I could have just simply done that on my calculator, 200 times 0.21, if that's what you would prefer. Right. 42, that's really just 42 right there. It's the number of people out of 200 that said yes. That's 21% of 200. Okay. It's the same thing. Okay. So that's how the StatCrunch works. You're just going to get your z-stat and p-value for free. You got to do the rest as far as the conclusions. Okay, back to the handout. Last thing we'll do is rejection region methods. So we'll run through at least one of those. And we've seen rejection region before. It's just the one where you have to find critical values as opposed to the p-value. Okay, so we'll try this one. And we'll rework the whole thing. So even though we've done this one before, need HOHA. Okay, so less than 50%, P less than 0.5 is the claim, P greater than or equal to 0.5 is the HO, left tail. When we go to find our z-score, it's the exact same as the p-value method. So I'm just going to cheat and go look that up. This was redoing example 2. So that one right there, we got that negative 2.20. Okay, it would be the exact same work for the rejection region method. But now, instead of finding a p-value, you're going to find a critical value, z sub 0, right? And that's based off of this level of significance. It's 0.01. So I'm just going to look it up on this little table. 0.01, left tail, there it is. It's negative 2.33. Okay, and then the way this works, to make your conclusion, draw that left tail, and the critical value is right on that shaded region right there. Now we're going to plot the z, which would be slightly to the right. And then that means if it's not in that shaded region, it's fail to reject H sub 0. And then the conclusion stuff is the same. Right? So just look back on example 2 and you'll see the conclusion. There's insufficient evidence to reject the claim. Okay. So what's different about this one? Finding critical values instead of p-values. Sorry, there's insufficient evidence to support the claim. I think I said reject. You're probably like, whoa. Yeah, insufficient to support. Okay, we got one more. We can cheat a little bit because a lot of this is what we've done already. There's that number 5 again. We just did it. Right? So we've got, let's go back to H sub 0, H sub A. I'm just going to rewrite this stuff. So that was equal to, not equal to, two-tailed test. We found a Z. Let's go back and just look at what was it? There's the Z. It was negative 1.31. Okay. All of that will be the same. Now you're going to find that critical value based off of a level of significance of 0.1 and the fact that it's a two-tailed test. 0.1's right there, two-tail, plus or minus 1.645. That's Z sub 0 critical value, plus or minus 1.645. Draw it out. This one has two tails. The tails are defined by those critical values. And then now, in whatever your favorite color is, plot Z which is not in the rejection regions. So this one again will be fail to reject H sub 0. H sub 0 was the claim. Fail to reject it. There's insufficient evidence to reject the claim. So the keywords there are insufficient to reject. It's that same sentence over and over. There is insufficient evidence to reject the claim. Okay, that's it for this chapter. Hope all's well out there. Talk to you later. Bye.